Welcome to the AI for Good interview series, in which we discuss the opportunities and challenges presented by artificial intelligence development with some of the leading voices working in the field today. Our guest for this episode is David Hanson, the founder, chairman, and chief creative officer of Hanson Robotics, a world-renowned and celebrated pioneer working in the field of empathetic and intelligent machines. James Hodson, chief executive officer of the AI for Good Foundation, opens the discussion which follows by asking David to share his thoughts on the dynamics of human interactions with technology. From there, they talk about a host of topics, including the nature of intelligence and adaptation, the necessity of collaboration between researchers and developers across many different organizations, and what breakthroughs in AI might be needed for robotics to take the next leap ahead.
So one thing that I remember reading is that there are some instances, especially with therapy, where the fact that it's a robot instead of a human also has some advantages in terms of allowing people to open up more than they might otherwise. So I understand the advantages of it being really human-like in terms of appearance, but there is also something in terms of people knowing it's not a human that can help with the therapy aspect.
Absolutely. So we just did a series of experiments in 2017, 18, and pushed it forward a little bit in 2019. We were calling it originally the Loving AI project, the goal being to create AI that enhances human well-being. And ultimately, if the AI becomes sentient, we want it to be capable of love in the highest sense, the sort of like the Greek word agape, meaning the love of humanity. And so we created this therapeutic regimen for guided meditation therapy with some psychologists and psychiatrists with the Institute for Noetic Sciences. In particular, Julia Mossbridge was a part of that program. We were also working with the Hong Kong Polytechnic University. A therapeutic regimen where the robot is designed for depression therapy, but we, in the IRB and psychology studies, did it with healthy participants. What was really interesting was that people responded. They really opened up to the robot. They engaged in the interaction. So the overwhelming majority of test participants had feelings of well-being. About 25 to 30% said that they felt a sense of bliss. They came out of it feeling better connected with other humans and with a kind of a sense of a bond with the robot. They said specifically, though, that they felt like that the reason that they opened to the robot was because they felt that they weren't judged. It was this kind of blank slate. So, people didn't believe that the robot was sentient, and yet they felt this sense of connection. So we have now a number of these experiments involving extremely realistic humanoids that show that they potentially can be very useful in these kinds of therapy applications. And, one of the interesting things is that people wind up being very polite and interested in robots like our Sophia robot and these other human-like robots. A friend of mine who's a psychologist at the University of Auckland, Elizabeth Broadbent, she studies robots with many different forms and virtual avatars in these kinds of therapeutic settings, finds that the more realistic the humanoid depiction in these interactive agents, the more empathetic people are. So it winds up connecting the people back to this human social connection. I think that, and this is somewhat speculative, but I really feel that this activates the circuitry of that social consideration. We're naturally socially intelligent. When we're at our worst, that social intelligence can turn into, mob rule, but that's not the de facto. The best social intelligence is where we are raised to our most elevated state, where we have compassion, where we really care, where we're more considerate. That's the kind of technology we need, is technology that brings us up to that level. The whole thing with deep fakes and weapons of mass persuasion is that they usually bring people down to their most base level. So this is, in a way, the two paths that we can use technology. One is to raise us to our best, and the other is to bring us to our worst. So we face an age where the easy way out for companies and governments and advertisers and this kind of thing may be to create these technologies that bring us down, make us our worst. And what we have to do with efforts like AI for Good in serving the United Nations Sustainable Development Goals is find a way to unlock the codes of the human nervous system that bring us to be our best. And I see that to be one of the greatest uses of robotic and AI technology.
Thanks for that. I think that's a really great way to frame it. A lot of the time, as you pointed out, if we're looking at things like advertising, where artificial intelligence might be used in terms of trying to, in some way, hack the human system and identify ways in which we can make humans act in a way that is predictable and that allows us to sell more goods or sell them at a higher margin and so on. But on the other hand, all of these tools, especially when we think about interactions on a social level day to day, have enormous potential for enhancing what we are doing and ideally also interacting with the SDGs to help us get closer to some big global goals for social development. And it's actually great also that we have this connection at University of Auckland because our chairman at the AI for Good Foundation is actually a professor in the computer science department at the University of Auckland, Michael Whitbrock.
I met him when he was working for Psycorp.
There you go. So yes, Michael and Doug Leonard have a long history going back also at the symbolic AI side, which is, I guess, where robotics first got its handle inside the AI research agenda. A great connection to have. And I would love to also ask you maybe a question about how, given the fact that over the past 10 years or so, we've seen artificial intelligence research move very much into a practically only statistical setting. Most of the modern machine learning infrastructure is optimization driven in terms of statistical algorithms. But there is this long history going back to Psycorp and other efforts over the past 40 years to bring the ability to reason about deep common sense in the real world, which is something that robotics, and especially embodied robotics, needs in order to be able to function with other human beings. Having given you that prompt, what do you think is an interesting area? How do you think we should bring these things back together?
The whole field and the nature of technology progress and scientific progress, we forget, is often about diversification and not mere reduction. I mean, it would be great if we could find some kind of single mathematical equation that would be a general theory of general intelligence, something like an EM equals MC squared formula for general intelligence. That's going to be really hard. I mean, especially when you look at all examples of intelligence in nature, and they're not simple, they're complex. Now, there might be some simple underlying principles. We know there are, but it also seems like there are many chemicals and cell structures and macro structures that are correlated with learning, intelligence, emergence. I say these as different things because learning is not necessarily intelligence. And it seems like that for its most capable manifestation, intelligence is about emergence, the emergence of new ideas, of creativity, the ongoing evolution. So the statistical machine learning tools have proven to be very powerful, and particularly these multi-layer neural networks. Now with these kinds of adversarial networks, there's just so much opportunity there. And what works is usually what is going to get the most attention. What works the best is the easiest to apply, the easiest to scale. In the same way that there may have been a lot of potential in analog computing back in the day, but once digital computing became formalized and it was scalable, then everything went digital. So symbolic AI, however, can do things that statistical machine learning can't do. So far, you can't get the reliable reasoning, inference, complex chained model building that you can get from symbolic AI. You just can't get that from statistical machine learning. The best results seem to come from the combination of the two. There may be other techniques out there. I mean, genetic algorithms are incredibly powerful in some regards. So imagine that we see these technologies put together in many different ways, and we encourage diversity in this. To some extent, the research in academia is set up for this kind of diversification. There's supposed to be novelty in your paper. There's supposed to be novelty to the patents when they're applied for grant application. And startups, there should be something distinct. However, often the funding and attention goes to those things that are considered to be validated, right? So then there's this natural tension that occurs between the conventional wisdoms of the fields and the necessity and power of the diversification of ideas. However, the tools for exploring new ideas are unprecedented. We can try new things We can combine new pieces of software far more easily today than ever before. And a lot of researchers are starting to talk about neural symbolic hybrids, and we're starting to see more and more implementations of that. Inside Hanson Robotics, we are using a neural symbolic hybrid architecture, which has been put together with a few scientists inside the company and outside the company. We've been working with the OpenCog Foundation for some years, which has a symbolic AI framework, very classical label-weighted hypergraph. This label-weighted hypergraph has a statistical representation within that, so that you've got statistical weightings on the nodes and links, and you've got a predicate logic network, and you can do some inference. So, I mean, it's in some regards, it's very similar to the McCarthy and the work done by Doug Lynott with the psych and so forth. So with this kind of atom space, you can create these formal logical representations of the world. You can build models, but usually those are handcrafted models. That's just the way that stuff works. Building the tools to take unstructured data, process it, for example, through statistical machine learning, and then once you have your models, represent them potentially as a hypothetical representation. You can create a hypothesis and then strengthen it by testing that within your formal symbolic logical representation, and then taking some of that and using that to tune your neural networks, using that to even put together new parameters into your neural networks, or potentially set up new fitness functions for genetic algorithms. These approaches are very exciting. They're experimental, but some of the results are really promising. It would seem to me like that the international community would team together to put together a kind of integrated toolkit and really encourage the integration across these multiple disciplines to experiment, put together new intelligent systems in new ways. I mean, that's sort of spontaneously happening, but there's not like an international moonshot right now for artificial general intelligence. AGI is still outside the quest of many, maybe most AI researchers. There is this kind of almost antiquated mythic quest to accomplish artificial general intelligence, and it's sometimes seen as something that's maybe distasteful in the field. But for those people who are seriously trying for artificial general intelligence, often they come to the conclusion, like Gary Marcus comes to the conclusion, that a neural symbolic hybrid is really the only way in the short term to achieve something like AGI.
It's good that you keep mentioning people that have been involved in creating the AI for Good Foundation. Also, Gary was an early person involved in the creation of the organization. So I completely agree with you. The right way forward is probably, as it is in most scientific endeavors, going to involve give and take from all of the different communities and new ideas and so on, especially when you think of the huge complexity of what is able to be learned by the deep learning community today, and yet evaluating inconsistencies in an inferential manner, having concepts that can be worked with in a way that humans work with them, like soft, fungible concepts that we can reason about very quickly. That's not yet something that has emerged out of these large networks. And yet it's something that most humans do as a process of understanding the senses from the real world, that hopefully we'll be able to do better.
As we're experimenting with making machines smarter, it's not just a matter of shaking up the jar and kind of sorting through all the different combinations of these technologies. I really do see that we've got an opportunity, and it's important for us to approach this with asking the question, what is general intelligence? In its full manifestation, it does seem to be many different things. It's always in the context of the best working examples of a general intelligence. It's in the context of organisms. And organisms are inherently complex, which means that there's a kind of a certain irreducible set of components. That complex adaptive nature of organisms is a kind of architecture that we don't really have in our machines yet. So you don't have it in AI, robotics, artificial life. And where it does exist, it's more almost biomimicry rather than bioinspiration from first principles. So there's a very large body of knowledge related to adaptive complex systems in nature, including organisms, and yet we can't create full synthetic life from scratch. You don't see the full capabilities of organisms. So there's a lot of science to be done there. And I wouldn't just say neural symbolic hybrid is the answer. I certainly wouldn't say computational biology or computational neuroscience as a subset of computational biology would be the answer. You just can't build a disembodied brain. I feel that what we need to do is study organisms, ideally in this quest for those fundamental principles. And we don't necessarily have to understand all those principles. If we have enough where we can get the initial conditions right, then you might have living algorithms that pop into life and evolve. I mean, after all, nature didn't necessarily need to understand all the first principles in order to engineer life into existence. It emerged. You get the conditions right, and it pops into existence, and then continues to evolve, facilitating new emergence, the kind of blind watchmaker miracle of Darwinian evolution. And so if we can get just enough of the first principles, we might be able to get this to happen. And in that laboratory of our AGI research, we may then be able to understand those first principles better by seeing these beings emerge in some way. So I'm proposing that we take this more organic organism type approach, this synthetic organism, or I would call it a holistic or whole organism architecture approach to our AI and robotics research. Embrace the complexity, embrace the interdisciplinary nature of this undertaking.
Absolutely. So I think from my perspective, I feel that all of the disciplines involved are still strikingly far from being able to achieve the types of things we just talked about. However, given that we're so far away, that also is an opportunity for us to start thinking about what the best routes might be towards this. And my own opinion on this front is that so machine learning for the past 20, 30 years that it's been a term that people have really been playing with has been focused very much on understanding what is the informational value that we can glean from data that we observe or from signals that we observe. It's really about optimizing decision making so that we minimize some cost of making a particular decision or minimize the error of making that decision and so on. And it's always been poised in terms of one particular way of thinking about the world, one particular problem, challenge, etc. Now, of course, symbolic AI, slightly different in terms of almost cataloging. You can think about it coming from information sciences and logic and so on. This is kind of understanding as much about what you know as possible and formalizing it as far as you can. But where I think we have the largest opportunities is actually in robotics, because robotics has always had to deal with embodied systems. It's always had to deal with interfaces between things, right? It's like merging different technologies together, bringing things in from outside and being in this real world, which is messy and noisy and horrible to work with in almost every respect. And yet, on the other hand, that's the environment that we have to work with for everything, right? There is no other option. We are in the real world, and ultimately we have to learn how to deal with it. And so far, machine learning stylizes the real world in order to cope with it, or potentially uses APIs to play games that are stylized versions of the real world. But that's still so much less complex, as you said, than having to actually be there talking to somebody who has autism or dealing with a medical intervention and things like that, where the moving parts, the variables are just open-ended. And having said that, and you may or may not agree, but having said that, what do you think are the next breakthroughs in AI that we need for your robotics to basically move ahead, take that next leap?
So I definitely concur. I don't want there to be any misunderstanding. We're far from having machines that are fully alive and conscious, and there's nothing like artificial general intelligence. We can surpass what seems to be generally intelligent capabilities in very narrow domains. Playing Go, winning at Jeopardy, these seem like generally intelligent tasks, but the algorithms are not generally intelligent. They're not adaptive. You can't just take them and apply them easily in their setting. They're pretty much fine-tuned for whatever the task is. So we've got a long way to go, but we need to name what the goals are and discuss what's missing and what some of the approaches are for maybe getting closer. We've got a quest. We've got to keep pushing the boundaries of our dreams into these unknown waters. The practical applications for these technologies today don't require these fundamental leaps. We can take what we have now. We can take these kinds of social human-like robots and non-human-like robots. We can take AI algorithms, we can use them in all kinds of powerful ways that make life better today. So there's creativity required for both, because taking today's technologies and using them to better the world now sometimes is not so evident. And doing it in such a way that it results in a sustainable business is also very, very hard. Recently, there was a big intelligent robot startup called Rethink Robotics, out of MIT. This whole company was about cobots, collaborative robots that could adapt to people. They'd be safe around people. They'd work on the assembly line. They'd create a manufacturing revolution. But after a lot of funding and many years of effort, they couldn't make it in the marketplace. It's hard. It's really hard to make robots that really work. And so even with some of the smartest people on the planet, a clear opportunity for change, it's really hard to creatively solve the problems to make a sustainable business that can change the world. It has to be sustainable economically in order to make a difference in the world. Now, if we had robots that could work alongside people and deal with the kind of complex, unstructured environments of manufacturing, and just so you know, not everything is manufactured these days by robots. There's a lot of stuff in the world of manufacturing that can only be made by people because it's too complex for robots and machine learning. And those kinds of tasks are very similar to the kinds of tasks that we would need to solve for you to have, say, a garbage sorting robot. How are we going to deal with this massive waste problem on this planet? You've got all this waste that's showing up in the oceans, landfills are overflowing. It's a major problem. There's all kinds of toxic stuff, heavy metals in there, plastics. We could really use this kind of intelligent automation that could sort through all of that. Grab the plastics, sort them out, sort all the materials, and then reuse them. Use the food waste. Sort the food waste, process it, turn it into fertilizer for vertical farms. This kind of thing potentially could be done, but it's economically unfeasible right now, except in select settings. So it's going to take a lot of effort to change the world. If we had intelligent automation that could help with this, it could accelerate these necessary changes for a sustainable future. It has to be economically sustainable. It has to work economically. If the efforts like Rethink Robotics disappear, then all of that effort for those years is gone. It's tragic. The creative problem solving necessary to apply these technologies today for the world's needs is massive. Some of these technologies work really well, but making them make sense economically is going to be a big challenge. Then we've got a bunch of creative challenges because we can't hold still. We don't want to just realize the potential and make the world a maximally better place unless we keep pushing the boundary of what is known. We have to keep questing. And I think if we did have some breakthroughs in true living machines and artificial general intelligence, then it would really help solve all kinds of problems. Of course, since we're so far from it, we can also then stop to ask the questions. What would make such machines good? How could it go wrong? AI for good, then, for me, is about AI for good now and AI for good in this speculative future where we may consider that these really transformative new technologies and scientific discoveries will appear. And we can ask the question, what if? What will happen if we do have these breakthroughs? It's important to know the difference. If we're talking about what if, we're not talking about something that's going to change the world today. But what if 1 year from now or 1 month from now or right now, somewhere in this world, there's a lab where somebody has, say, cracked the problem of artificial general intelligence? It would be hard to say that it's impossible. What happens? Now, I don't want to waste all our time on dealing with that because we've got more pragmatic issues to deal with in the world right now. But I think it's interesting and kind of important for us to ask those questions.
I think that's a really good point. And thanks also for bringing up the economic constraint, which people often forget when we get carried away talking about how amazing the world can be because of the new research that comes out, and whether that's in AI or in biology or wherever it might be. We often end up going through this cycle where we get extraordinarily excited about the potential of that technology because we imagine it as if it's a complete open field. That now that the technology exists, that it's going to just permeate all of society by tomorrow, and then it will change everything. But the reality, of course, is that these economic frictions mean that it can often take decades, if ever, to permeate into society in a particular way, because you don't realize just that capital is ultimately still the main facilitator of these things, and consumption drives where capital goes. And if you don't have consumption patterns that match up, then it doesn't matter how cool your technology is, your business won't materialize in the way that you expect. But the way that we operate as an organization is exactly as you said. It's how do we best support the research community so that we have breakthroughs in the technology that will maximally impact our ability to solve these problems down the line. And I think that if we go to the research community and we try to be enablers and try to start those discussions about what the big challenges are today and where we can make some progress that will have an impact down the line. And if we can somehow societally set up incentive systems so that people do create sustainable business models that are for profit and can have an impact on these core challenges, ultimately that's what having a capitalist society is all about. It's about identifying ways to drive change with value for consumers that is for profit. And if you can align incentives that way, then it's probably going to happen faster than it would in any other system. So let me wrap up there and ask you the question, what do you think we can achieve that's big within the next 5 years with AI and robotics working together? It's not going to be artificial general intelligence, but what's a big area that you think we can attack in the next 5 years and solve from the perspective of the sustainable development goals?
So in the next 5 years, we could make a huge difference in the platform development. If we can develop a platform that many researchers and developers can use in a wide variety of ways, then that would transform the lives of developers in top-tier research labs, potentially putting powerful tools that bridge their efforts with the labs all around the world. And these could also include up-and-coming labs. If the development tools are low cost and easily accessible, then you wouldn't need a big capital investment. You could have people who learn these tools on the internet and use them in really disadvantaged communities around the world to contribute. I would like to see some of my colleagues, and I call this synthetic organism unifying language, that would bridge the language, the vernacular of many different disciplines to help to unify. There's a lot of fragmentation. I mean, artificial intelligence and cognitive science, they sometimes bump up against each other, but they're sometimes separate. And then you have computational biology and computational neuroscience that have their own language, sometimes for the same thing. The artificial life research community that are building these computational biology and complexity physics models, there's some overlap there. But then there's the entertainment simulation of life, where you have Weta Digital in New Zealand or Disney. You've got these companies that are trying to create the appearance of life, and that can be incredibly useful in the marketplace. But the tools and techniques for approximating life there are very different from the full physiology simulations that you see for research or for medical simulation markets. So you have this fragmentation. By looking to unify these into a kind of common language and common set of developer tools, then we might be able to breathe new life, quite literally breathing life into AI research and into robotics development. Robots that my team and I make at Hanson Robotics, they are superficially human-like when you look at them. Our quest is to make them human-like, the most human-like research platform, and to get these platform tools out there in the world. We're not the only ones doing this kind of quest, so we're also integrating with things like the robot operating system and all these ROS, all the different tools in that ecosystem, all these different kinds of statistical machine learning tools, genetic algorithms, and symbolic AI. But sometimes it's just simply overwhelming for a small team like ours to take this on. If we can coordinate with researchers, then 5 years is not unreasonable as a goal to put something like an emerging international standard for this kind of synthetic organism approach to artificial intelligence. Get that broad network standard. Synthetic organism unifying language as a acronym, SOUL, the soul, getting the soul into the machine. believing that this kind of holistic complex system approach to studying what makes organisms alive and what could make potentially artificial intelligence more capable would be a kind of soul in the machine. So 5 years, it would be nice to see this synthetic biology revolution in artificial intelligence reach a mainstream interest in the world of AI.
So platform, infrastructure, and access, it sounds like. And I think that's a great achievable goal. And I look forward personally to seeing the two fields, AI and robotics, as well as all the other ones that you mentioned, grow closer together and have some great cross-disciplinary fruit over the coming years, especially if we can get that to interface more with the big challenges that we've also been talking about during this conversation. So, David, once again, let me stop there, but thank you wholeheartedly for your time, and hope that if you're ever in the Bay Area, you can stop by and say hi to us, and we can show you some of the work we've been doing, and hopefully we'll continue the conversation.